Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're going to see problem number 2198 and 2982. Again, this is a follow-up. As you can see, there's a just constraint difference. In the first one, it is 50, and the next one, it is 5 into 105. Let's see. But before that, it's important. It simply says that you are given a string S that consists of lowercase English letters. As you can see, string S with lowercase English letters. Now, a string is called special if it is made up of only single character, which means that this triple D, double Z, F, anything which is of single character is actually good. Now, you have to return the length of the longest special substring of S which occur at least thrice, or -1 if there is no such possibility. As you can see in this example, longest substring which occur thrice, again distinct, will be this one, then this one, and then this one. Three substrings having length 2 is the maximum number of, again, this substring is good or special because it has same characters. So answer is 2. Here in this case, as you can see, there is no such even a single character which is occurring thrice. That's the reason answer is -1. In the next case, I can see A occurring thrice. Answer is 1. Length 1. So the first very basic, again, to actually try on to a bigger example and cover all the cases, I've taken this example. The first and a very basic naive approach which comes to our mind is, again, obviously the task is find the substring. The next task is to find its corresponding length and also make sure that it has same characters. So what I will do, okay, I will have a I, then I will have, again, obviously how you have two loops, right? Two loops to go and try for I and j. I will simply get the substring out. From I to j, I'll get the substring out. I can then check that for this specific substring if all characters are same or not. If yes, then just for this specific substring as a length, again for this specific substring, I will, again, maybe I can leverage length also, maybe, but I know that okay, this specific substring, update the frequency. So what were the steps here? The steps, first step was just iterating on ij pair. For this I, for this j, then the j obviously will move forward and so on and so forth. For a specific ij pair, when you have got it, make sure to get the substring between it. Then when you get that specific substring, check, iterate on that substring again and check if it is having same characters or not. If yes, then update its corresponding. Just you can take a hash map or simple unordered map in which you will simply say that for this specific substring the count is this one, and just update or add the count by +1. What is the complexity for this? Obviously O of n square to iterate on ij pairs. For any specific ij pair you will iterate on this string again, right? Just so as to know if all the characters are same or not. Okay, after you have done with it, then you will update that in your hash map. Because if I even say that this substring has a length of m, and that is the reason to iterate on it, it will take O of m time, but that m can actually be in worst case n of size n. Thus to iterate or to update that in hash map also, it will again take your O of n time. So this will be a complexity, which is O of n cube. Okay, and obviously that will also work. But can you optimize this very naive brute force also further? Obviously we can, because we know in the standard brute force approach, when we are generating substrings, for example ij here, then I know obviously it is a. Then when the j moves here, rather than actually going and checking the entire substring again, just check if this character is same as the last character, right? With that, your this step will be removed. With that, your this step will be removed. And with that, okay, as you know that okay, this is good, it is equal to its last character, which means this is good. I can update that in my hash map. And in my hash map, I will say for this specific substring, which is AA, simply increase its corresponding frequency by 1. Thus, I will increase it. And I will say for A, the frequency is 1. But because you're updating in hash map, that will still take your O of n time. So this portion is gone, but this portion of hash map is still there. Thus, the complexity is still n cube. right? Okay, and same way I'll simply keep on going on to my loops. Let's quickly see the code. It's very simple. Then we go on to the better approach. So firstly, as I know, I will have two pointers, I pointer and the corresponding j pointer, start and end. Then I will try to make sure I'm going on and checking if the current substring which I'm trying to build, if it is equal to the end which I saw just now, then I will just simply make sure, this is the one which I saw just now and this is the current character which I'm iterating on. If it is same, which means I'm continuing to a good, because I only want the substring having the same characters. So for me, any different character, it doesn't matter. For different character, I should actually break. Elsewise, I should make sure I should push that in my substring, and ultimately make sure to update your hash map. That is the prime thing. Why it is the prime thing? Because any substring, I want its corresponding frequency to be more than equal to 3. Then only it's actually good or useful for me. That length is useful for me. So I'll simply, ultimately in the end, iterate on the entire substring hash map. I will check the count is more than equal to 3. I'm good to maximize my length. Ultimately return the maximum length. Now, because of this, as you know, that time will be O of n cube, but space will be O of n square, because ultimately the space will be the worst case space which will be stored in your hash map. And your hash map is storing all the substrings. In a specific string, I can have n square substring. Each substring, again, when I say n square substring, which means, okay, if I have A, I can have, let's say, okay, let's take ABC. Let's say, again, taking the worst case, A. In that worst case, my substrings can be A, then AA, then AAA. That's it. If you are asking, Aryan, you would also have this specific substring? Obviously you have, but you are only maintaining A and AA, which is already counted here. Thus, I can say in worst case, I will have n substring, each can have length of n. Thus, the complexity of n square. But you might ask, Aryan, what about if the strings are different, A, B, C? In that case, I will not even have a AB. I will only have a B or a C, right? That is the reason my space is O of n square. Cool. Now, obviously, you want to optimize this much more further. How you will do it? If you would have seen the previous approach when I was iterating on my I and I iterated on my J, I always made sure that I am having the substring which I am making, this is of same characters. If this is something of same characters, then what is the need of actually storing the substring entirely? As in, if I know that substring is of A and obviously have all the same character, which is A itself, rather than storing the substring of length n, rather if I store one character and one variable or one integer, this will actually represent the internal substring. This will actually help me to optimize that portion of hash map itself. And that is the only change, that I leveraged and removed this n factor also from my hash map, and thus leveraging O of n square time. Again, because of O of n square, because of these loops, exact same approach as the previous approach, is just a small difference, that rather than maintaining the entire string as a substring in my hash map, I will maintain a character and the corresponding length of it. And for this specific thing, just maintain the corresponding count, which means increase the frequency if I encounter the same substring again. How I will do it? Exact same stuff what I did previously. I iterated on my I iterated on my J. I just simply made sure that I will only iterate when my current character, which I actually, because see, I want only the same character stuff. So I'll simply iterate if my S of J is actually equal to my current character, which I have. If yes, then increase the length. Now, rather than actually storing the substring, which I was actually doing in the previous step, which as you can see, current substring, pushback, and pushing by that character, I was storing the actual substring. Now in this case, I will simply make sure I'm increasing the length. And as you know that at every substring, you have to update your frequency map, which is your hash map itself. I will simply say that you can have a pair of character and the corresponding length and increase its frequency. Ultimately, exact same stuff, iterate on it. Any frequency which is more than equal to 3 is actually your answer. And thus, you are simply able to solve it. Now, what is the time for it? Obviously, time will be O of n square. What is the space for it? The space will be O of n. Now, you might ask, why O of n? Because obviously, you can say, okay, Aryan, I can have any characters, obviously. But you might say, Aryan, you only have lowercase character which is 26, but still you are storing the character and the length as a pair. Now in worst case, what if I have all same characters? Then I will have a1, a2, a3, a1, a2, a3 as a length. What if I have different characters? Then it will be a1, b1, c1. In any which ways, how many characters I have, ultimately I can have all same characters, thus giving me one character and all possible length options, thus taking O of n as the space. Now obviously it's O of n square, but if we saw the constraints of the problem variation of 2982, we saw it is not which O of n square can support. It is 5 into 1, which O of n square obviously cannot support. Then what can we do? So far we have realized, okay, I tried for ij pair, and then I tried to actually iterate on it, and I was making sure that I'm maintaining the character and the corresponding length, and for that, what is the corresponding frequency? This is the frequency. Now I know I have to optimize it, which means bring it to O of n, or maybe O of n log n, like this factor, because obviously beyond this it will not work. O of n square will not work. What I can do? The thing which I can leverage here is I will have to, no matter what, try to iterate on this only once, which means that I'm only allowed to iterate on this string once. Again, once, or maybe you can say twice or stuff, but not twice in the same loop. So, which ultimately brings me to a fact that I can only iterate on this. Oh, and also I was maintaining character, I was maintaining length, I was maintaining the corresponding frequency. Ultimately, I can do the same thing. Oh, okay, as I'm iterating towards this array, I can maintain, okay, A has what? A has a frequency of 1. A has a frequency of 2. A has a frequency, again, I'm iterating here, then I am here, then I am here, then I am here. A has a frequency of 4. You see what's happening? This is the character, which is A. I'm maintaining its length, which is actually this thing. And ultimately, you might say, but Aryan, what about the frequency stuff? You have to also maintain the frequency of all the variations of substring which you are actually having. I'll say you are exactly correct. But what all variations for substring I can have? For any character A which I have, it can have a length of 1, 2, 3, at max what? At max a length of n. That's it. So for any character A, I could only have at max length of n, and I just want to store its corresponding frequency. So I know the characters can be 26. The length at max can be n. Again, I'm saying n possible options of length can be there. Frequency it's simply a variable which also can be at max n. Then why, if what I'm trying to store itself here is this much, then why in this world I'm even trying to go for ij and making it O of n square? Can't I simply bring it down to this? Obviously I should be able to do it. So what I will do, okay, I know that I was iterating on this thing. As I was iterating on this thing in my string itself, I will make sure, okay, a, okay, a length, okay, so far the length is 1. I'm simply iterating and maintaining the count of a character. This is the count, this is the count, but again count of characters such that the character is same. So far the by default count is 1. Any character is obviously occurring one time, so this is by default 1. I'll simply move my I pointer. Okay, A is, again, here I am maintaining its length, and obviously I'm maintaining the frequency. Count and length are in sync, both are same technically in this case, and this is a character for me. So, okay, so far it's 1. Obviously, I will increase the frequency of it. Then I will move my pointer. Then, because it is the same character, I will obviously compare characters in my code, that if I am moving next, it should be same as the previous character. In that case, my count should increase, which means my length also increased. But obviously, I need to make sure that for different length, I'm trying. Okay, for A as a length of 2, I increase its frequency. Then make sure again you move on that, okay, A Next time the count increased, which means the length increased. Okay, again the frequency. Then again make sure you move on. Okay, then again the count increased. Actually you see the frequency also. Then oh, B is not same as A, which I saw previously. Count will reset to 1. Okay, so B, frequency of 1, reset to length of 1, reset to 1. Okay, then A, oh again it is not same as the previous one, which means again it resets to 1, which means for A as a length of 1, increase its frequency. A is already there, so increase its frequency. Okay, then move on. If I move on, oh, again it is same, increase the count, which means for a length of 2, increase the frequency. Okay, move on. For again length of 3, again increase the count. For the length of 3, increase the frequency. Now, you will see that ultimately what my maqsad was, maqsad नहीं बोलना है, ultimate aim was to actually get for the maximum length. For the maximum length, what is the corresponding for the which is happening thrice. This was like this was my use case. Now, if I look at this problem, I can easily see I have this data with me. With this data, can you figure out what is the frequency of every possible substring length? How can I do it? What I try to ask you is that for this specific thing, you might say, Aryan, this answer indicates that for A as a character, having all same characters, a string of length 3 as a substring has only twice as the frequency. But I will say no, you are incorrect, because the two which you have counted is actually this one and this one. You never counted this thing, and that is the reason you were taking O of n square time in the previous approach. So how can you leverage this fact, and how can you make sure that you are also counting plus 1 for one more substring which was possible? For that, I will take the fact that always take the maximum length substring first. With that, there is no possibility of having any other substring impact on it. So I always know one thing for sure, that A having a length of 4 is only having one length. Okay, this is the maximum possible length I could have right now. Obviously, I will start at trying from the length of 8, but for your case, I'm just shrinking it down and telling, okay, at this point, let's start off. So I know, okay, this is maximum length. So okay, for the maximum length, I know the frequency itself is 1. I wanted the frequency of 3. This is not my answer, which means 4 is again I have to maximize the length. So far it is 0. I cannot do anything. I will simply move on, go to the next smaller length. But as I go on to the next smaller length, I know that a length of 4 can give me 2. Again, can give me 2 length of 3. Sorry, 2 length of 3. And I also know one fact, that when I was counting a length of 3, I already counted one of them. So I will simply say, oh, that is true. So I should make sure I should deliver him 1 for this specific extra stuff. And again, if I show you parallelly in the code, it is easily visible that in your small length, you are actually adding the corresponding high length, because you know that for a length of 4, if I would have said, that okay, this is a, and if I would have said that okay, this is 1 2 3 4 5 6, for the length of 6, it will give me 2 length of 5s, but one length of 5 is already there. So one length of 6 is giving one extra length of 5. That's it. And if I have, let's say, 5 such things, or let's say if I have 3 such things, now you might say, Aryan, if you have 3 such things, won't it be a very big thing? No. Let's say if I have some delimiter, let's say B or another character, then this thing, which means length of 6 has a frequency of 3. So that length of 6 having frequency of 3 will impact length of 5 3 times, and that too just once, because you saw that a length of 6 will deliver 1 extra to a length of 5. So this length of 4 will deliver 1 extra to the length of 5. Again, 1 extra for only 1 as the frequency. So this will deliver 1 extra. So this will become a 3 in this case. So, oh, you will realize, okay, this was the maximum length. Okay, you maximized your answer. Obviously, you will stop for A itself. Again, you will try for different characters B, C, D up till Z, but you stop for A because you have achieved the maximum length. Who? Because you're iterating from the backwards with the maximum length, so you know this answer. But still, for your simplicity, I will still go backwards and tell you how it will actually impact. If you go back, considering if you would have gone back, how much would you add the impact in this two? What this 3 indicates? This 3 indicates I have one this as a substring, one this one, and one this one. Now, this 3 indicates that I can add twice, which means for 1 3 again, let's leverage out of these 3. Let's take one of them. Out of this one of them, this will be how it looks like. This is already included. The first one is already included in the 2. The next one is what we are trying to include here. So I know that this one of them will impact once, 3 of them will impact thrice. So I'll just simply add a plus 3. This will become a 5. I will have 5 such them, like 5 such, as you can see, 1, 2, and if I just do it, 3, 4, 5. Cool. And same way, when he will go back, he will add a plus 5 to the him. Again, this is a bit of observation based, so you don't have to worry about, okay, how things are happening. This is a bit of observation based. Now, this is actually what you have to do. So cool, let's see the code. It's exactly same. I took, again, you can take a hash map also, but then you have to handle the cases separately in the last case. So here I took, as you can see, for every character, just get the corresponding frequency. You know, to actually grab the frequency, we have multiple ways. We have hash map. We can also take leverage of the array to think of it as a hash map. That's what I have done here. Then I go on to all the corresponding indexes, or you can say lengths. Then I went on and say, okay, this is the current character. It should be the same as the last character. In that case, I will increase its length. If that's not the case, then I will reset the length to 1. No matter what, for that specific character, for that specific length, increase its corresponding frequency. Ultimately, when my map is done and built, or you can see my array is done and built, I will iterate for all the characters, iterate on the corresponding lengths, but in the reverse order. Lengths in the reverse order. Then I will make sure that if, obviously, if my length is less than n, I have to make sure for the current length, just add the higher length exact value to myself. For the current length, for this current length, whatever answer I have, just add the higher length answer to myself. Okay, so now I get the correct frequency of my length by adding the high length to me. If that is more than 3, I am good to say maximize my answer and then break, because I'm iterating backwards in the length. So this is the maximum length which I could achieve for this character. But again, next time try for the different characters, ultimately getting your maximum length, because you know you are simply trying to iterate on the things just once. So time is O of n for the first loop and O of n into 26 for the second loop, which is again constant. Space here will be O of n 26 because obviously you are using a array of fixed size, which is n into 26. Cool. Bye bye. Take care. I hope you guys got it. I hope this was properly good. If yes, then please smash the like button. If you liked it, again, if you liked it. Bye bye. Take care. Do join on Discord and Telegram. And Twitter is a bit of masala right now.